Welcome to today's video. Today we're focusing on using the z-score formula to find the z-score, mean, standard deviation, or a missing element. Again, we're going to show that mastery in class by scoring at least an 80% on an exit ticket. Hopefully you have your note sheet in front of you. If you don't, take out a sheet of paper and we'll get you a fresh one tomorrow. Now, z-score is a score that shows how many standard deviations away it is from a mean. Now, if it is a positive z-score, the data lies above the mean, and negative z-scores lie below the mean. One thing you'll notice, anytime we did standard deviation problems on the notes or in class, it was always positive standard deviations, 1, 2, 1.5, 3. Z-scores can be positive or negative. Now, we have our all-important formula down at the bottom. X is our element in a set. That mu, cursive U, is your mean. Again, in the calculator, it's the same thing as X bar, and we can still use that if we need it. And your sideways 6, or an O with a tail, is your standard deviation. Now, the good thing is that formula is on your algebra formula sheet. It just doesn't tell you what things are, so make sure you have that part memorized. If we look at example 1, the following set of numbers is given. First of all, we would use our calculators just like we've been doing. Find our mean and find our standard deviation. Our mean is 53.33 and our standard deviation is 18.86. Now, for a z-score of 30, what we're going to do, if z equals x minus mean over standard deviation, well, we know my element is 30 because that's my score, minus my mean, and all over my standard deviation. Here's one thing to check yourself. If my mean is 53 and I have a score of 30, it's below it, so my answer better be negative. In this case, if you do the math, you end up with negative 1.24. So it is negative 1.24 standard deviations away from the mean. The second one, it says 60. We're still using that same formula, but now with the z-score, it's going to be 60 minus 53.33 over 18.86. In this case, 60 is above my mean, so it's going to be a positive z-score, and we're going to get a z-score of 0.35. And that makes sense because that number is close to the mean, so it's not going to be that many standard deviations away. Now, the last one says how many elements have a positive z-score. Well, positive just means it is above the mean. My mean in this case is 53.3. So how many numbers are above that? Well, if I look, I have 60, I have 80, and I have 70. So there are 3 answers, and if it asked you for them, it would be 60, 80, and 70. My other 3 numbers would have a negative z-score because they're below the mean. Now, example 2. Jill made a 95 on her test. The mean of the class was 70 and the z-score is 10. What is the standard deviation? So again, when it talks about z-score, we always want to go back to our formula. Z equals my element minus my mean all over standard deviation. So now we're going to fill in what we know. Jill made a 95 on her test. That's not the class average, that's what she got. So that's going to be my x. The mean of the class was 70. Well, mu, or that cursive U, is my mean. And the z-score is 10. So I'm going to put 10 out there. What is the standard deviation? Since I don't know it, I'm going to call it x. Now, we need to be able to solve for that x. I'm going to subtract my top, and I get 25 over x. Well, from here, multiply both sides by x to get rid of the fraction, and I get 10x equals 25. To get x by itself, divide both sides by 10, and you get x equals 2.5, which means my standard deviation is 2.5. It's a positive 2.5, but that makes sense because my mean is 70, my test score was a 95. It should be positive, it's above the mean. Example 3. Jacob made a 45 on his test. Standard deviation was 12. His z-score was negative 1.5. What was the mean? Go back to our z-score formula. We have element minus mu over standard deviation. He made a 45. Well, that's my element. The standard deviation was 12, and his z-score was negative 1.5. We don't know the mean, so I'm going to put x there, or you can put mu. Well, I can't solve the top in this case because we can't do 45 minus x, so I'm going to start and multiply both sides by 12. I end up with negative 18 equals 45 minus x. I need x by itself, so 45 is positive. I'm going to subtract it, and I get negative 63 equals negative x. Well, this is like saying I have a negative 1, so I'm going to divide both sides by negative 1. That means x is equal to 63, which in this case is my mu. My average is 63. And if we look, he had a negative z-score, so that means his test score fell below the average. Well, his test score was a 45, and that's below 63. So it does make sense. Our last one, Kaylee's mean when running is 4.5. If her standard deviation is 1 mile and her z-score for today is negative 2, how many miles did she run? Again, let's go back to that z-score. My element minus mu over standard deviation. So Kaylee's mean when running, so her mean is 4.5. If her standard deviation is 1 mile and her z-score is negative 2, how far did she run? Now, I know dividing by 1 doesn't change the problem, but just as a reminder, when you have a fraction, multiply. So negative 1 times, or 2 times negative, 1 times negative 2 is negative 2, and you get x minus 4.5. Well, if I need x by itself, I'm going to add 4.5 to both sides. This gives me 2.5 equals x, which means she ran 2.5 miles today. And if we talk about it, she has a z-score of negative 2, which means it's going to be below the mean. Well, 2.5 is below my mean of 4.5. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.